In today's lesson, we're going to be looking at finding tangent equations. So I want to take a look at some questions where you involve the chain rule for finding tangent equations. In particular, the focus will be on these horizontal tangent equations. Well, tangent's horizontal when the derivative is 0, so go ahead and take our s prime at t. Now we're going to drop down that 6 and treat this like the power rule. That becomes a 5. Now again, we have to take the derivative of the inside because that wasn't just a t, it was an entire rational function. So we're going to do the quotient rule now. So it'll be bottom times derivative of the top minus the top times derivative of the bottom divided by the bottom squared. Continuing on, s prime of t is 6, 2t minus 1 over t plus 2 to the power of 5. I'm going to go ahead and distribute that 2, in which case we get 2t plus 4 minus 2t plus 1 all over t plus 2, quantity squared. Continuing on, we have s prime at t is going to equal 6, and then we'll put down our rational function here to the power of 5. And we're going to go ahead and clean up the top here. When we clean up the top, we'll notice the 2t's cancel. And I'm actually just left with a 5 on the top and a t plus 2 squared on the bottom. Putting this all together, we get 30, 2t minus 1 to the power of 5 over t plus 2 to the power of 7. And again, don't forget this power of 5 is applied to the numerator and denominator. Putting that together with a base of t plus 2, power of 2, gives you a power of 7. So now I want to know when is this going to equal 0. So we set our derivative equal to 0 here. And we're looking to solve for t. Now notice here, this expression will only be 0 when the top is 0. When the bottom is 0, those are values where your function is non-differentiable. Those are not values where your function, in this case s prime at t, is equal to 0. The only way that this can equal 0 is if the numerator is 0, in which case when we solve for t here, we get t is equal to a half. Recall this was our definition of s at t. I want to find the actual point, not just the one coordinate, the t coordinate. So I'm going to sub this back in here, in which case if I evaluate s at a half, you'll end up seeing here when you sub this in, you sub this into your numerator here, you're going to get 0 in the top, and we get s at t is 0. So therefore, our answer for this question is the point where the tangent has a slope of 0, or horizontal tangent, is the point 1/2, 0. All right, let's look at another. For the next question here, they want us to find all the points such that the following function has a horizontal tangent once again. So horizontal tangent we know has a derivative equal to 0. Let's go ahead and calculate our derivative first. So if I go ahead and calculate f prime at x, we're going to go ahead and apply our product rule first. So it's going to be the first times derivative of the second is -3 plus the second times, if I take the derivative of the first, I drop down the 4, subtract 1, and then the derivative of the inside is 2x. Now I want to simplify this up a bit because I'm going to end up setting this equal to 0, in which case here you'll notice I can factor out x squared minus 1 term in both these locations. So I can actually factor out power of 3 of these. So I'm going to go ahead and factor that out of here, in which case I get x squared plus 1 to the power of 3. And I'm left with -3 times x squared minus 1. Plus putting together the 4 and the 2x, we end up getting 8x times 2 minus 3x. And notice here, this is completely gone now because I factored out 3 of them. So now continuing on here, let's set this derivative equal to 0, in which case here we get x squared minus 1 to the power of 3 minus 3x squared plus 3 plus 16x minus 24x squared. And continuing on here, we're going to go ahead and I'm going to apply difference of squares to this expression here. And when we do this here, we get x minus 1 to the power of 3 times x plus 1 to the power of 3. And collecting up like terms here, we get minus 27x squared plus 16x plus 3. Continuing on again here, I'm going to factor out that minus sign. We get x minus 1 cubed times x plus 1 cubed times 27x squared minus 16x minus 3. So notice here, we want to find when this is equal to 0. Well, I've got one root is going to be 1, another root is going to be minus 1, and then this quadratic here, if we do a discriminant check on this quadratic, you get the discriminant is b squared minus 4ac, and calculating this, we end up getting 580. So positive discriminant means this has two real roots. We're going to go ahead and use the quadratic equation to find those. So using the quadratic equation, we get x equals negative b plus or minus the square root of 580, we just calculated it, over 2 times 27. Calculating these, we end up getting two values, x equals 0.74 and negative 0.15. So notice here, these are approximate values. So when x equals 0.74 or x equals negative 0.15, those are two values where your tangent equation is 0. Also, we have x equals 1 and x equals minus 1. Let's go ahead and find the points. So subbing all these points in here, we've got one point is 1, 0, the other point is negative 1, 0, the other point is approximately 0.74, negative 0.01, and then lastly, negative 0.15 and approximately 2.24. Again, I got the corresponding y values by just subbing into your original function, not your derivative, subbing into your original. So that concludes today's lesson on horizontal tangents. Thank you.